Coming up next on Seeing in the Dark.
Looking through a telescope, it opens up an entire new world. I mean, there's always this wow factor. I can't believe that I'm actually seeing this.
This program was made possible by the National Science Foundation, where discoveries begin. And by contributions to your PBS station from viewers like you. Thank you. The sky is like water. On this side, the bright, familiar world. On the other, the mysterious depths. Look through the sky, into the starry depths, and you'll find more out there than anyone has imagined or can imagine. And it all starts close to home. I started exploring the night sky 50 years ago and got so involved in it that I eventually constructed a permanent home for my telescope on Sonoma Mountain. Once the observatory was built, I was unpacking some old books from back home, and I found my original journal. And in it was a blueprint drawn when I was about 13 years old for an observatory. It envisions a one-story structure, but otherwise it's identical to the building I'm standing in. As they say, all dreams begin in childhood. Amateur astronomers say they love stargazing, which is what the word amateur means, to do something for the love of it. But it can be hard to put love into words.
It opens up an entire new world, or entire new worlds, I think. And just by looking and I've been through it so many times, and I always anticipate that moment, like the first time a kid sees Saturn. I mean, it's the same way that I was when I first saw it as a grown man. I mean, there's always this wow factor. I can't believe that I'm actually seeing this.
To have a telescope and to look beyond the limits of the Earth is one of the greatest things that we can all do. The stars are intangible, something that humans cannot touch, beyond our reach, and it lends itself to wonder.
The supreme challenge of astrophotography is that we're imaging exceedingly dim and distant objects as they move across the sky under very low light conditions. It's an extraordinary technological challenge, but it's extremely fulfilling, and it's very addictive. So I found myself kind of consumed by the hobby.
There's so many stars in the sky that professional astronomers can't look at them all. So chances are when I'm looking at a star, I'm the only one on Earth looking at that star at that moment in time. Knowing it's my data and my star, and it's sort of a possessive feeling of being in the right place at the right time and being the only person on Earth paying attention right now to that star.
We had just confirmed the presence of a planet orbiting a star. I ran outside and I found the star, and then my view widened as I took in the sky just filled with stars, and imagined that most of them had planets, maybe with beings looking back at me.
The grandeur, absolute grandeur, getting out under a dark sky, seeing the Milky Way arch from one horizon to the other is I can't imagine anybody not being totally awed by that kind of a sight.
Isn't that beautiful?
You ever dream about these sights?
Oh, sure.
Yeah.
Don't you?
Yeah.
Yeah.
There's something indelible about them.
Yeah, you go to sleep and you see stars behind your eyelids. Yeah.
Space and time are kin. When you look at a star 1,000 light years from Earth, you're seeing light that's 1,000 years old. With a telescope, you can see galaxies whose light is millions of years old, and quasars more than 5 billion light years away. Their light is not only older than the hills, it's older than planet Earth. I started stargazing in rural Florida in 1956. I was 12 years old. I'd learned from library books that the Earth was not the world, but a world, a planet, and that if you had a telescope, you could see something of the other planets. Mars was coming close to Earth, growing brighter in the sky every night, and I wanted to have a look. My first telescope didn't show much, but I could make out the white polar caps and dark continents of Mars, and I wanted to see more. I mowed lawns for the next few years to make the payments on a better telescope, and formed an astronomy club with a few friends from high school. On clear nights, we'd pack up our telescope, binoculars, and star charts, and set out to explore the dark night skies that adorned Florida in the 50s.
WQAM Miami.
The moon, the sun, the stars in the sky. It was a futuristic time when Americans drove cars that resembled rocket ships, and real rockets were soaring into space from Cape Canaveral, 200 miles north of us. One night I took a time exposure photo of a rocket arcing across the sky, headed for the moon. It fell short by almost 200,000 miles, but you could tell that the planets, which had been alluring sights through a telescope, were becoming destinations. Watching the Echo 1 satellite glide overhead, brighter than most stars, we could sense that space began close to home, just a few hundred miles up. The universe wasn't all that far away. We lived in the universe. Back then, we had big skies and small telescopes. We couldn't observe much beyond the moon, the planets, and a few bright star clusters. We had a lot of fun, though, and came to cherish the telescope as an instrument of deliverance, the key to a vast and spectacular kingdom. We marveled at the battered gray moon. We watched storms larger than Earth churn across the face of Jupiter. We peered into globular star clusters that hang over the galaxy like starry chandeliers. Such things were so big, so beautiful, so old or hot or cold as to balloon our sense of the plausible. They produced a sensation that I could not put into words at the time, but later found expressed in Einstein's description of his first encounter with science, that it showed him a way to free myself from the chains of the merely personal, from an existence dominated by wishes, hopes, and primitive feelings. Out yonder, said Einstein, there was this huge world, which exists independently of us human beings, and which stands before us like a great eternal riddle, at least partially accessible to our inspection and thinking. The contemplation of this world beckoned like a liberation. At night, when broadcasts from distant radio stations bounced off the ionosphere, we could hear music from far away while looking farther still. That's how we first heard the blues, wafting out of our portable radio with the vicissitudes of what we called the ozone. I came to think of music and the stars as landmarks to steer by. I didn't yet know that this was already an old story back when Kepler and Galileo talked about the music of the spheres, but I could sense a resonance between the night sky and the tricky matter of plucking a few strings in just the right way to put human hearts in tune with the cosmos. Nowadays, amateur astronomers have better equipment than they did when I was a boy. The global positioning system on Robert Smith's telescope lets him find stars too dim to see in the light-polluted skies over Miami. Robert is a sometime football coach who likes to introduce his players to the wonders of the night sky.
Because it's a GPS scope, all you have to do is enter in an object, and it takes it to you and stays with it as the Earth rotates. When you look at the sky, it sounds hokey, but it's like a connection to the infinite. Everything looks so tantalizingly close, and when you know how far those things are, you know that you could never get to them in your lifetime, but you could see them instantly by looking through an eyepiece. And that's amazing to me, and that's the greatest part about actually viewing the sky to me, is knowing what it is that I'm looking at, knowing the process that created it, knowing the life cycle of it, and then realizing just in a general sense how far away it is. And I can still see it. It's incredible.
Robert retired at age 29 after establishing himself as the best running back in the history of the Minnesota Vikings. He quit at the peak of his career, saying that having learned how to play the position, he no longer found it intellectually stimulating.
When I think of science, I don't just think about discovering facts or observing. I think about it as more of a philosophy, and questioning everything and examining everything. So now it takes diligence, not just accepting what you're being told, but carefully examining all angles of any issue. That's the great thing about science. It doesn't start with a conclusion and then try and fit the facts in. It takes the facts and you work towards a conclusion. Once you can start seeing individual stars, just focus off to the field of view on the side somewhere, and then you'll be able to see it a little bit better. I think we're good here. We just give it a shot. Anybody, go ahead. Give it a shot. Andromeda's pretty much right in the middle of the field of view. And then once you're able to see stars, focus your eye off to one side or the other, and then that hazy patch in the middle is the galaxy itself. I like looking at the galaxies, imagining something or someone being in those galaxies hundreds of millions of years from now, seeing you, millions of years after you're gone. Things like that just kind of blow my mind.
Some stargazers still build their own telescopes. A century ago, the 32-inch reflecting telescope that John Vogt made in his garage would have ranked among the wonders of the astronomical world. Today, it's a transportable instrument that he and his daughters, Patty and Jennifer, can set up in about 15 minutes.
Pull it, the brass piece in the front.
With a telescope this large, you can see bright stars in broad daylight, and by night perceive some of the colors of dim nebulae that otherwise are apparent only in photographs.
Great job.
For over a century, amateur telescope makers have met annually here at Stellafane, Latin for shrine to the stars, to test their handiwork under the dark skies of rural Vermont.
That sonotube is beefed up?
No, it's sewer pipe beefed up.
Yeah. I didn't even need to be beefed up.
Yeah.
These parts look vaguely familiar to me, these plastic parts. Where have I seen these before?
You've seen them in the plumbing section of the hardware store.
Yeah, that's what I thought. So this is PVC.
Yes.
So there are 2 entire telescopes in this one tube, 2 complete optic paths.
When there is information coming into both eyes, there is a 40% increase in contrast of any object viewed,
40%.
as opposed to just closing an eye and looking through one telescope.
Some people like looking at the moon, some people like looking at the sun, some people like planets. Some people like to make mirrors, but kind of like making a whole telescope. It's kind of like my part of it that I like.
What's it made of?
It's irrigation pipe.
It's irrigation pipe?
Yeah.
And then you got a nice handle here, which
Yeah.
is something a lot of telescopes lack. I know a lot of the
Motorcycle
ones I've used.
handlebars, yeah.
Really? Is that what that is?
It's just a
It
stick.
seems like, yeah, it does give you that feel, doesn't it? That
Yeah.
you can really pilot it. Wow, I bet you get nice images with a long focus refractor like that. Stellafane was founded in the 1920s by the engineer and explorer Russell Porter. Porter's experiences in the Arctic, where he was shipwrecked and stranded for a year, prompted him to construct an igloo-like observatory at Stellafane, where he could study the stars from the comfort of a warm and closed room. Stellafane retains an egalitarian quality of seemingly ordinary people making extraordinary things to put themselves and their neighbors in touch with the great beyond.
Hello, everyone. My name is Normand Folhomme. I live in Hudson, near Montreal. I am a telescope maker as a hobby. Myself, I'm a planetary observer. I love to look at the planets and the moon. And when I'm sitting down looking at the rings of Saturn or the cloud bands of Jupiter, thousands and millions of kilometers away, it blows my mind. It's every time. I've been observing for 25 years, and every time I look at the Saturn, it takes my breath away. It's like, wow, it's so good.
This is something I put together with leftover cedar strips I had from a canoe project that I made a couple of years ago.
The corrector lens was ground during the days of Hurricane Gloria in 1985. There was no electric power, and there was nothing else to do in the house, and too early to go to bed. It'll rotate 360 degrees around. I've always wanted that in a scope, never had it, and I finally got it. If I wanted anything else better, I'm just going to make another telescope.
The light from the sky comes down and hits the concave primary mirror. And then that's focused up towards the eyepiece, and there's a flat mirror here that bounces the image out of the focal plane, so out of the axis of the scope, so you're not in light. And then an eyepiece here that magnifies the image.
The idea is to turn it at the rate that the Earth is turning so that it will follow an object in the sky. And you can do that by just squeezing this bicycle brake handle, and it turns that little wheel, and you can get it to rotate at just the speed that the Earth is turning so that the object you're looking at will stand still in the field.
Let me line it up. Should be about there. Can we give it a shot?
Sure.
Looking at Jupiter,
Wait,
and
what
it's
are we
about
looking at?
10 times bigger than the Earth in diameter, but about 1,000 times more massive than the Earth.
Whoa.
When you observe celestial objects, you can think in the context of what's known about them, or you can think in the context of what's not known about them, right? And I think once you get to the point of thinking in the context of what's not known about them, then it becomes quite interesting.
Today, more people can get a glimpse of the big picture, thanks to the efforts of groups like the San Francisco Sidewalk Astronomers, who offer city dwellers free views through telescopes they've fashioned on the cheap. They get surprisingly good results, making their telescope tubes from salvaged concrete casting molds and their light-gathering mirrors from ordinary window glass.
And what you're looking at there, that's Jupiter.
That's fabulous.
You like it?
Yeah. Whether you build, borrow, or buy a telescope, the aim is to see nature beyond the range of everyday human experience. Sometimes a stargazer makes a discovery while observing simply for the love of it. That's what happened to Steve O'Meara, a hawk-eyed observer who taught himself astronomy as a boy.
My first memory as a child was of an astronomical experience. I was sitting on my mother's lap and we were looking up at an intensely red lunar eclipse. This brilliant red ball, and I thought this was marvelous. And that color just burned itself into my soul, and I wanted to learn more.
Steve learned the night sky so well that Harvard University gave him keys to its observatory when he was 14 years old.
For many years after school, I came to the observatory, I observed with the telescope, I went to the library, I studied the books, I met the astronomers. I lived here. The beauty of this observatory is that the directors knew how to observe. This is truly a temple to the stars. It really is dedicated to observing one object all night, perhaps for years. The telescope can be just moved simply by the hand, and once you're seated, you don't want to leave.
Steve calls himself a 19th century observer in the 21st century. He likes to use telescopes the way astronomers did before photography was invented, by spending hours looking intently at just one object and making drawings to record its elusive details.
The way I observe as of many years ago is still visual. There are very fine moments where everything just becomes pristine and sharp. And it's in those moments that I'm able to pick out the finest detail on a planet.
Scrutinizing Saturn through this old telescope, young Steve sometimes saw dark radial features crossing Saturn's rings like the spokes on a wheel.
When I made my first observations of the spokes, it was deemed impossible.
Astronomers dismissed them as an optical illusion until the Voyager space probe reached Saturn and photographed the spokes.
This was a moment of elation for me. I felt sincere happiness, but at the same time, I was thinking back to the scientists of the 18th and 19th century. They would look and could only wonder at what they were seeing.
Saturn's rings are 200,000 miles wide and less than half a mile thick. The spokes may consist of dust particles that pick up an electrostatic charge from lightning in Saturn's atmosphere, leaping up off the icy rings like scraps of tissue paper levitating to a comb. Our galaxy contains about 1 trillion planets orbiting stars beyond the sun. Nobody has yet managed to see one of these exoplanets directly, but astronomers have found indirect evidence of hundreds of them circling nearby stars, and now many amateur astronomers are getting into the hunt. Their approach is to look for planets transiting distant stars. When Venus passed in front of the Sun on June 8, 2004, it functioned as a miniature solar eclipse, blocking about 1% of the Sun's light. Too subtle to be noticed by the eye, the dimming can be detected with a telescope and digital camera, not only for the Sun, but for many other stars as well. Planets form from disks like giant versions of Saturn's rings. They're too small and dim to be seen in the glare of their parent star. But when a planet happens to be oriented so that it transits its star as seen from Earth, the slight dimming of the star's light shows up as a light curve. The shape of the curve reveals not only the presence of the exoplanet, but how large it is and how long it takes to orbit its star. An amateur astronomer who first records such a light curve has, in a sense, discovered a new world.
So when I saw that little planet go in front of that star, I was thinking and looking up in the sky that that planet actually passed in front of that star when Abraham Lincoln was president. To me, that's tremendously deep.
From his home observatory in Pleasanton, California, Ron Bissinger spotted the telltale dimming of a star 150 light years from Earth that signaled the presence of a transiting planet.
I'm very, very fortunate to be in one of the areas of science where a rank amateur such as myself can sit in the backyard and actually contribute to science. Usually I shoot for about 45-second, 60-second exposures. Deborah Fisher and I have been working for several years through this group called Transit Search. Deborah identifies stars that have potential exoplanets. What they don't know is whether the exoplanet is transiting.
There aren't enough professional astronomers to carry out the intense monitoring of stellar brightness that we need on all of our stars. So one of the things that's been wonderful is to have an organized group of amateur astronomers to follow up and look for the transits.
The more planets we find, the more we learn about them. The more we learn about them, the more we understand the likelihood that there could be life elsewhere out in the universe.
I'm looking at a star that's almost identical to the Sun. It's known as HD 98618, and it's located in the bowl of the Big Dipper, only 126 light years from Earth, which is right next door on the galactic scheme of things. But even at that close distance, it's too dim to be seen with the unaided eye. If we lived there and we looked back our way, the Sun, too, would be just one star among many seen from the eyepiece of a telescope, and the Earth be too dim to see at all, even with our most powerful telescopes. Kind of makes you wonder just how many other small worlds there are out there, unknown to us, each with a story waiting to be told. The Sun and the Milky Way's 100 billion other stars have all played roles in the galaxy's history. And one of the pleasures of stargazing is to perceive how each individual object fits into the galactic ecosystem. Stars form in the spiral arms of galaxies like ours, and it is mainly the light from the hottest young blue-white stars, which live fast and die young, that sets the arms aglow. These new stars blow away the surrounding dust and gas to announce their birth to the wider world. Panning along the Milky Way with binoculars or a low-power telescope, you can see the products of our galaxy's star-making machinery. What the poet John Milton, having interviewed Galileo on the subject, described as a broad and ample road whose dust is gold and pavement stars. When stars die, much of their material is vented back into the galactic ecosystem to be recycled into new stars. Space is littered with the departing shells of exhausted stars, each as intricately patterned as a shed snakeskin. The nearest spot where you can see new stars being born to replace the old is the Orion Nebula, 1,500 light years from Earth. "30 light years wide, the Orion Nebula harbors enough material to make 10,000 suns. But on the galactic time scale, its existence is fleeting as a flower that blossoms for but a day. Soon, having created a bouquet of new stars, the nebula will fade to black. Time exposure photography made it possible to discern the anatomy of the Milky Way galaxy from our perspective inside it, rather like Jonah tracing the ribs of the whale that had swallowed him. The word photography was coined by an astronomer, and the first man to photograph a human face, John William Draper, whose sister Dorothy posed for him in 1839, also made the first photograph of the moon later that same year. Edward Emerson Barnard, whose photographs would reveal the structure of the Milky Way, was born into poverty in Nashville during the Civil War and put to work in a photographer's gallery at age 8. Barnard's boyhood was, he said, so sad and bitter that even now I cannot look back on it without a shudder. To soften the sadness, as he put it, Barnard sought companionship in the night sky. I got to know the stars so well, he recalled, that I would miss them as I would have missed a friend. And when they again came around, I welcomed them as I would welcome that friend. Books were Barnard's salvation, and his life changed when he borrowed a book about astronomy, a subject he'd scarcely known existed. Comparing the book to the sky, he discovered that others had studied the stars long before him, unheralded shepherds of old, and the ancient Greeks and Arabs, naming the stars and linking them to form constellations. In less than an hour, he recalled, I had learned the names of my old friends, for there was Vega and the stars in the cross of Cygnus and Altair, and others that I had known from childhood. He would always remember that night as my first intelligent glimpse into astronomy. Barnard grew up, got married, and enrolled at Vanderbilt University simultaneously as both a student and a teacher, sweeping the skies with a small telescope that friends made him from a broken spyglass they found in the street. He enjoyed stargazing for its own sake, noting that everything in the sky is interesting and numberless objects are beautiful in the extreme. But cameras can reveal what the eye cannot see, and he soon devoted himself to astrophotography, shooting pictures while keeping warm in a tattered coat made of reindeer hide. Using an old portrait lens, Barnard mapped the Milky Way's glowing reefs of stars, which he said resembled the billowy clouds of a summer afternoon. At first, Barnard thought the dark regions were gaps between the stars, but his opinion changed when he studied a black cloud in Orion called the Horsehead. The Horsehead Nebula was identified on a photographic plate in 1888 by Williamina Fleming, who was working as a housekeeper for the director of Harvard College Observatory when he recruited her as an astronomy researcher. Barnard and other astrophotographers eventually found that bright patches like the Orion Nebula are just the most conspicuous parts of a much more extensive system of black clouds that run through the galaxy like the roots of a forest. Historically, a few painters have tried to depict nature by night, as when Samuel Palmer recorded this view of the great comet of 1858 as seen from Dartmoor in Devon. Photography is the medium of choice for modern artists of the night, like Akira Fuji, who took this shot of Comet McNaught over Australia in 2007. And Rob Gendler, who photographed the Andromeda Galaxy, known as M31, in remarkable detail through a portable telescope from his home in suburban Connecticut. Inspired by the photos he saw at New York's Hayden Planetarium as a boy, Rob started shooting pictures from just outside his garage. His equipment consisted of a small, high-quality telescope, a digital camera, and a laptop computer. Rob reduced local light pollution by shrouding the nearest street lamp under a barbecue cover.
From an ordinary place, a driveway in a fairly light-polluted suburban location, you can image distant worlds that are 30, 40, 50 million light years away, clusters of galaxies in a few minutes. That's what keeps me going in astrophotography, the anticipation of that fresh sense of discovery that comes with every image. A big project I did, I set out to do a long focal length mosaic of M31. I made a chart, I planned out the frames and the exposures and how I was going to proceed with the mosaic. I started at the core of M31 and I added more frames, and finally got to this point after about 40 frames, about 50 hours of imaging over 3 months' time. And then I used color data from an older image to make a color version of this long focal length mosaic of M31.
When he'd done all he could from the suburbs, Rob had a telescope installed at a high-altitude location called New Mexico Skies. He's taken thousands of photographs with his new telescope over the internet, but he's never visited the site nor ever seen his observatory.
It's kind of an amazing thing that it can actually be done, to be able to image 2,000 miles away from a dark sky observatory when you're sitting in the comfort of your home.
Rob Gendler's telescopic images reveal a universe full of colors that the eye can only dimly perceive. Most of these clouds lie within a few thousand light years. Within a few tens of millions of light years loom hundreds of bright galaxies, some resembling the Milky Way. A spiral galaxy seen edge-on silhouettes the dark disk of dust and gas from which new stars will be made. Farther out, we encounter cannibal galaxies, like this giant elliptical swallowing a spiral in a painless but spectacular consolidation. Each galaxy is a bright efflorescence on invisible oceans of dark matter, evolving and interacting over time. One such galaxy gave rise to our sun, the Earth, and us. What else, and who else, have the other galaxies made? Meanwhile, the average human's view of our own galaxy has deteriorated to the point that only 1 in 5 persons alive today has ever seen the Milky Way. To avoid light pollution, many astrophotographers now take their photos with remote-controlled telescopes. To find out how quickly such an internet telescope could be set up, we dispatched an experienced crew to New Mexico Skies. Their mission? To establish a working telescope at this amateur enclave in an empty dome, equipped only with electricity and a web connection. Team Bisque consists of 4 brothers who taught themselves astronomy and went on to develop systems that enable amateur astronomers to control telescopes from anywhere in the world that offers internet access, whether it's an apartment in Chicago or an internet cafe in Istanbul. The first step is to install a computerized mount that can point at any object in the sky and track it accurately during each time exposure photograph. The telescope is a commercial, off-the-shelf instrument that combines a lens and a mirror to produce a flat image suitable for astrophotography. The digital camera uses an air-cooled imaging chip to reduce thermal noise. It's good gear, but the whole rig cost no more than the automobile the Bisques brought it up in. Once it's hooked up to the internet, the imaging system can be tested from 1,000 miles away. Hello. Hey, Tom, how you doing?
I think we're good to go. Everything looks like it's in good condition. Go ahead and pick a target.
All right, let's see. I'm going to M109. Spiral Galaxy should be bright enough for a short exposure.
She's moving.
Now, according to me, it's on it now.
From what I can tell of it, yes, it should be there now.
Now, let me try take a short exposure here and see. This will just be enough to tell whether it's pointed at the galaxy. And yeah, there it is. Hey, that's amazing. How long did it end up taking you all together?
Oh, this, I'd say, total 3 hours.
Well, that's amazing. Well, thank you. Talk to you later.
It's almost unbelievable that light that's come from, say, 2.5 million light years away is now photons that have been gathered somewhere else in the world that are sitting there on your monitor.
As soon as we got these systems completed, the amateurs were breaking all the records for discovering minor planets and supernovas. And now it's at the point where lots of science can be done and discoveries will be able to be made by kids sitting at their computer with maybe their parents telling them to hurry up and get to bed, but they can actually collect scientific data, reduce it, and do astronomy, whereas before this, if you're not a professional astronomer with a big telescope, you're not able to do that.
This is a very exciting avenue to open some minds, expose them, show them, teach them, and let them feel like even though I may not have the opportunity, I can pursue this and I can contribute.
Absolutely, for me.
You can't help but change your view of this world when you sit out in the wonderment of space. I mean, it just opens up your mind that you have to start to try to contemplate and grasp what's out there.
How far can a backyard stargazer see? Consider the story of a giant star that exploded in a distant galaxy long before the Earth was born. The remains of the star formed a black hole that spat out a jet of high-energy light called gamma rays. Moving at the velocity of light, the gamma ray burst sped across space for 11 billion years, reaching Earth on April 18, 2006. A NASA email announcing the event reached the musician and amateur astronomer Michael Koppelman at the little observatory he built in Minnesota for about the cost of a new motorcycle. Michael set out to detect a glint of light from the explosion before it faded from view.
I've been on the email list for gamma ray events for a few years. There's a new satellite up there that's detecting them quicker than we ever have. And what's cool is they basically have a system when that gamma ray burst goes off, there's an email in my email box sometime around 60 seconds afterward. Getting there fast is the whole thing with a gamma ray burst because they disappear so fast. One night I was in my little warm room and I saw the email. I was like, oh, cool, GRB. And I looked up the coordinates and it was like 5 degrees above the horizon, which is in the trees for me, I mean, right in the weeds. Just a little starlight was coming through and it got out of the trees and I was taking pictures and I looked at them and I didn't see anything. Went back, started looking at the data, and once I'd kind of stacked it all, I found the glow. And I looked it up in the catalogs and double-checked the position. It was right where they said it would be. I calculated how far away it is, and it was further away than the known universe. Like, there wasn't enough time since the universe started for the light to get here. And I was like, wait, what the heck? So it turns out you have to fold in relativity and all this stuff. And then when you do, you get a distance, and I think it was around 11 billion light years away. I just love to show people this picture to say, you know, this dot, this little pale blue dot, this left 11 billion years ago, you know, like the Earth wasn't here when that light left, you know, like that's pretty amazing that I have a CCD detector that big that caught probably literally a couple hundred photons from this thing, you know, it's pretty dang cool. As a musician, you're searching for this sort of messy perfection of it all fitting together right, and like it adds up to 0 at the end. No rounding errors, no nothing, it's perfect. Like Einstein said about physics, there's a perfection when you get to the right answer. I mean, E equals MC squared, 3 letters. 3 letters and a number, and it tells us so much about the world, And yet we get so wrapped up in the things we get wrapped up in that we don't realize that really the universe is so big we can't really explain or understand it. The questions never end. They start at the beginning of the universe and they end at the end of the universe, and it's all this complexity in between. So, I sort of finally found something that I could never exhaust, as hard as I try.
Michael Koppelman's capturing of ancient light followed in the footsteps of another musician turned amateur astronomer, William Herschel, who probed deep space 2 centuries earlier. As a teenager, Herschel played oboe in his father's unit, the Hanoverian Foot Guards Band, but deserted on his father's orders when they came under attack by the French during the 7 Years' War on the 26th of July, 1757. Herschel fled to England and settled in the fashionable town of Bath, where he became a successful conductor and composer. He was awakened to the wonders of the night sky by reading a popular book called Astronomy Explained by Jamie Ferguson, who had learned the stars as a shepherd boy tending his flocks. He set to work making his telescopes and eyepieces by hand from mahogany and crocus, the woods used in the oboes he had played as a boy. I determined to accept nothing on faith, he said, but to see everything with my own eyes. Observing for decades on virtually every clear night, Herschel sketched thousands of spiral nebulae. He thought they might be new solar systems forming, and he didn't live long enough to learn that each spiral was actually a galaxy of stars millions of light years away. But he was more justified than he realized when he said, toward the end of his life, "I have looked farther into space than ever a human being did before me."
I got a hold of copies of William Herschel's work and was amazed at what he was able to see. He made some mistakes, but he also made some very intuitive guesses about the structure of the universe, the Milky Way.
Barbara Wilson is a visual athlete who was inspired by Herschel's example to seek out dim and distant objects that others assumed they could never see. Hey, Barbara, what are you looking at?
A little open cluster in the Milky Way, NGC 1907.
Oh, yeah. Yeah, that's quite. This is one of the objects that Herschel observed in his great sweeps of the galaxy.
One of his open clusters he picked up that other people didn't.
Barbara interrogates the night sky.
It's part of the,
She's shown me things that few have ever seen, like the plasma jet protruding from a black hole at the center of a galaxy in Virgo. We once tried, without success, to see a gravitational lens, the slivered images of distant galaxies magnified by the warped space surrounding galaxies closer to home.
When you look deep into the cosmos and you realize that these objects may no longer exist, that the light has traveled across the eons of the universe and into your eye, it gives you a different perspective on life in general. If people would just, spend some time looking out, looking up, and it's just beautiful, just beautiful.
You could spend many lifetimes exploring our home galaxy, but its neighbor, the Andromeda Galaxy, just over 2 million light years from Earth, proffers a particularly alluring view of light dating from the dawn of the human species. The Andromeda Galaxy happens to be tilted in such a way that starlight reaching us from its far side is 100,000 years older than the light from its near side. When light from the far side began its long journey to our eyes, the first true humans did not yet exist. By the time the near side light started out, they did. To see a galaxy is to see time.
Wake up, mama, don't you sleep so high. Wake up, mama, don't you sleep so high. For it's season blue.
Today's automated telescopes can photograph hundreds of objects on their own without human intervention, leaving stargazers free to meditate anew on time, music, and the stars.
Big star falling, mama take long for day. Big star falling, mama take long for day. Maybe the sunshine will drive these blues away.
Yeah, that's nice. Whose song is that?
Blind Willie McTell.
1920s?
1927.
Remember that Blind Willie Johnson song that Dark Was the Night? And, NASA put it on Voyager, shot it right out of the solar system. Sounds like we got our galaxy images for the night. We'll go check them out. Well, it's not bright yet, but it's getting there. You want to take a look at the Whirlpool Galaxy while there's still time?
Sure, I'll grab an eyepiece.
You know, using a telescope's a bit like playing a musical instrument. What you get out of it depends on how much you put into it. You know, when you look at this galaxy, try looking a little away from it, what they call averted vision.
Yeah, I can see the spiral arms. How far away is it?
30-some-odd million light years.
After the dinosaurs.
That's right. It's around the time of the first bears, early whales, long before human beings.
Here comes the sun.
The fireplace of the world, as Johannes Kepler called it. You know, Kepler put his reputation on the line to defend Galileo's observations against the professors and priests who claimed that telescopes only produced optical illusions. Kepler even wrote an ode to the telescope. "Oh, you much-knowing tube, more valuable than any scepter."
So why did people refuse to look through Galileo's telescope?
Yeah, dogma. Not just religious dogma, but the dogmatic habit of mind, the idea that everything worth knowing can be found in the pages of some allegedly infallible book. Galileo studied what he called the book of nature. And in the 4 centuries since, we've turned maybe the first few pages of that book. And all the rest of it's still out there, waiting to be discovered. There's virtually no limit to what we can learn.
Sounds too good to be true.
Well, you know what Michael Faraday said about that?
The guy who invented the electric motor?
That's him. Blacksmith's son. Taught himself science, found the connection between light and magnetism, set the stage for Einstein's uniting of space and time.
What would Faraday have thought about that?
Within the laws of nature, he said, nothing is too wonderful to be true. To download a star chart for your location and get involved in the night sky for yourself, visit the Seeing in the Dark website at pbs.org. This program was made possible by the National Science Foundation, where discoveries begin. And by contributions to your PBS station from viewers like you. Thank you.